9-2 Composition of reflection. Our objective to find composition of reflection including line reflections. Theorem 9-1, 9-2, and 9-3. Theorem 9-1 is a translation or rotation is a composition of two reflections. You can see from number 15 that triangle EDF reflects over the line L, the line I, and then K, which then form into rotation. And number 16, triangle MNO reflects over the line P and then Q, which then form into a translation by combining two reflections. First, start with line L and M being parallel, and construct your R, and then you reflected it across line L by using this method to reflect across line L, and then we need to reflect it again over line M. You can use the same circle method to draw the reflection across M, but to save time, we're gonna transform and reflect across line M. So the image of R reflected first across line L and then across line M is a translation, and the distance of the resulting translation is 25.53 centimeters by measuring same point on the first and the last reflection.
Theorem 9-2 is the converse of Theorem 9-1, which are a composition of reflections across two parallel lines is a translation, and a composition of reflection across two intersecting lines is a rotation. And problem 2, line L and line M intersect at point C to form an acute angle that measure up to 70. What is the image of R reflected first across line L and then across line M? What are center of rotation and the angle of rotation for the resulting rotation? First, we start with reflecting R over K and over K, and then reflect again over line M. We can see that this forms a rotation from reflecting 2 times, and to measure the center of rotation, we need to connect connect the same point on the first image to the last image, and then we measure the angle. So the angle of rotation for the resulting rotation is 140 degrees, and you can see that the center of rotation is line L because no matter how you move it, it just stays there and the angles just change. Theorem 9-3 is as following. In a plane, one of two congruent figures can be mapped onto the other by a composition of at the most 3 reflections. The vocabulary that we need to know is acute reflection. It is a composition of a translation and a reflection across a line parallel to the direction of translation. From the glide reflection, you can map the direction and where the image moves to. Problem 3, finding a glide reflection image. What is the image of triangle TEX for a glide reflection where the translation is xy arrow xy minus 5 and the line of reflection is x equals 0? First, we have to move the triangle down by 5 according to the y. 1, 2, 3, 4, 5. Same with the x. And then we connect it together. You can see that it formed weak. And then we reflect it across y axis. And now this is the image of triangle TEX for glide reflection. Thank you.